Hi everyone, it's nice to see you in this video. In today's video, we're diving into the top 13 essential date and time formulas in Excel. Whether you're managing schedules, calculating deadlines, or just trying to keep track of time, these functions will help you get the job done efficiently. These formulas aren't just useful for daily tasks. They're also powerful tools for data cleaning and data analysis. And here's some exciting news. After this video, I'll be sharing more advanced date and time functions in Excel, followed by a video where we'll tackle real-world tasks using these formulas. By the end of this series, you'll have a solid understanding of how to work with dates and times in Excel like a pro. So, let's get started. The Today function in Excel returns the current date as a serial number, which is the code Excel uses for date and time calculations. This function is particularly useful when you want the current date to appear on a worksheet, as it automatically updates whenever the workbook is opened or modified. The Today function doesn't require any arguments, and you can easily format the return value as a date. To get the current date in Excel, simply type =today into a cell. Excel stores dates as sequential serial numbers, so adding 1 to a date effectively advances it by 1 day. Subtracting a number from the Today function will return a date that is that many days in the past. The same logic applies for finding dates for 2 weeks or 2 months. To find a date 2 weeks from now, you would add 14 days. For 2 months, you would add 60 days. The Today function is essential for various tasks, including those requiring a specific time. By combining Today with the Time function, you can create a timestamp with the current date and a designated time. Simply input the desired hour, minute, and second values into the Time function and add it to Today. To customize the date and time format, navigate to the Home tab and click on the Number Format section. This will open the Format Cells dialog box. Under the Number category, select the Custom option. In the Type field, enter the desired format using codes like M for month, D for day, YYYY for year, HH for hour, M for minute, and SS for second. You can arrange these codes to suit your preferences. To quickly apply the same formatting to another cell or range, use the Format Painter tool. Simply select the cell with the desired format, click the Format Painter button, and then click on the cells you want to format. Then try to do the task as same before. Now we have a table containing events and event dates. To calculate the days until an event, click the cell where you want the answer, type an equal sign, and then subtract the Today function from the cell containing the event date. This will show you how many days are left until the event occurs, which is useful for tracking schedules. Here, we have a simple task of tracking project deadlines. There is a table with 3 columns: project names, deadlines, and tracking. In the tracking column, I added this formula. Today, this function returns the current date, H16. This is the cell reference containing the deadline for the project. If this function checks a condition and returns one value if it's true and another if it's false. Condition. Today, H16 checks if the current date is greater than the deadline. True value. If the condition is true, the deadline has passed. The formula returns overdue. False value. If the condition is false, the deadline has not passed. The formula returns on time. Now, let's apply conditional formatting to this column. Go to the Home tab, click on Conditional Formatting, then New Rules. Select Format only cells that contain, and apply green formatting to cells with on time and red formatting to cells with overdue. You can apply this same technique to other similar tasks. We're going to explore Excel formulas that allow you to format the current date in different ways. Let's break down this formula step by step. Equals the current date is and. This part simply adds the text the current date is to the beginning of our result. Text, today, MMD, this is where the magic happens. Today, this function returns the current date. Text, this function formats a number, in this case, the date, into a specific text format. MMD, this is the format code we're using. MM represents the abbreviated month name, e.g., Jan, February, Mar. D represents the day of the month, e.g., 1, 2, 3. Next function is now. Let's learn it with examples. The now function returns the current date and time. It automatically adjusts the cell's format to match your regional settings. Use this function to display the current date and time or perform calculations based on the current time. The now function has no arguments. To display the current date and time, simply type the equal sign in a cell and enter the now function. Similar to the today function, if we want to show yesterday's date but the current time, we subtract 1 from the function. To show tomorrow's date but the current time, we add 1 to the function. Here's how to do it. Give it a try yourself. Next, let's add hours to the current time. In this case, we'll add 0.25 to the now function, which equals 6 hours, since 0.25 of 24 hours is 6 hours. The task in B8 is similar to the previous one. If we want to return the date and time 12 hours earlier, we simply subtract 0.5 from the now function. The value 0.5 represents 12 hours, since 0.5 multiplied by 24 hours equals 12 hours. For any week or month, we can subtract or add the number of days contained in that week or month. For format the current date and time in a specific format, we will do this with this formula. Let's explain the formula step by step. Equals text. This function is used to convert a value to text. Now, this function returns the current date and time. Format underscore text section is the format string that specifies how the date and time should be displayed. 3y represents the year as a 4-digit number. 3m represents the month as a 3-letter abbreviation, e.g., Jan, February, Mar. 2d represents the day of the month as a 2-digit number. 2h represents the hour in 12-hour format, 0, 1-12. 2m represents the minute as a 2-digit number. 2s represents the second as a 2-digit number. Now we have daily task tracking Excel. First column is task names. Second column is current date and time, which comes with now function, and third column is deadlines. For calculating how many times we have to till the deadline, we just subtract deadline from current date column. And then we should change the format of the result custom format. And here we will write the format like this: D for days and H for hours. We can use this function in many tasks as we need. Next function is date. The date function generates a date based on the provided year, month, and day numbers. The output is a serial number that corresponds to a specific date in Excel. The year can be specified with 1 to 4 digits. If the year is between 0 and 1899, Excel assumes it's a year after 1900. For example, date 108-1-2 creates January 2nd, 2008. The month must be a whole number from 1 to 12. The day must also be a whole number from 1 to 31. Let's see an example of creating March 15th, 2024. We'll input 2024 for the year, 3 for the month, and 15 for the day. You'll notice that the default format might not be what you want. To customize the format, go to the Custom Format section and choose the desired style. If you don't find the desired style, you can create a custom one to suit your preferences. You can certainly use cell references to provide the year, month, and day values for the date function. This offers more flexibility, especially when working with dynamic data. To see this in action, look at this example. It will create dates from this values. We have another simple task to practice the date function. Imagine a table containing project data. The first column lists project names, and the second column has their original dates. In this exercise, we'll increase the year of each date by 5. To achieve this, we'll use the date function. For the year argument, we'll apply the year function to the date column and then add 5. The month and day functions will extract the month and day from the original date. In real-world scenarios, you might need to adjust the month or day as well. To do this, simply add the desired number to the corresponding argument within the date function. Now, let's explore some interesting behaviors of the date function when we input values that seem unusual. First, what happens if the month is greater than 12? For example, if we use the formula equals date, 2024, 14, 25, Excel will automatically add the extra months to the next year. So, 14 months from January 2024 lands us in February 2025, making the result February 25th, 2025. Next, if the month is less than 1, say we use equals date, 2024-3-25, Excel will subtract months from January 2024. In this case, minus 3 months brings us back to September 2023, so the result will be September 25th, 2023. Now, what if the day exceeds the number of days in the specified month? If we use the formula equals date, 2024-8-38, Excel will push the extra days into the following month. So, 38 days into August 2024 moves us to September 7th, 2024. Finally, if the day is less than 1, for example equals date, 2024-8-5, Excel will subtract days from the previous month. Here, minus 5 days from August 1st, 2024, brings us to July 26th, 2024. In this part, we're going to dive into the Excel time function. This function is used to create a time value based on specific hours, minutes, and seconds. Let's start with the basics. Hour represents the hour value, ranging from 0 to 23. Minute represents the minute value, ranging from 0 to 59. Second represents the second value, ranging from 0 to 59. Firstly, try to create this sample using the time function. Type time function, then input 5 for hour, 25 for minute, and 30 for second. If the format is not how you want, you can change it from format cell and would choose any format you want. The time function in Excel converts any value exceeding standard limits, 0 to 32,767, accordingly. For example, an hour input of 27 becomes 3 a.m., 750 minutes convert to 12:30 p.m., and 2,000 seconds turn into 12:33 and 20 seconds a.m. In this example, to get the hour, we divide 750 by 60. The result is 12.5, which means 12 hours and 0.5 times 60 is equal to 30 minutes. Let's use cell references for the time function inputs. In this small table, the first column is for hour values, the second column is for minute values, and the third column is for second values. Let's write the time function using cell references and then drag down the formula to create a list of times. As same before, you could change the format and customize it how you want. Now let's look at another example. In this example, we'll add hours to any time. We have a table with 2 columns. The first column contains times, and the second column contains the number of hours we want to add to the corresponding times in the first column. This formula takes the time from the first column and uses the time function to convert the value from the second column into hours in the same format. In the future, if you need to add minutes, you can modify the column reference for the minute argument in the time function. Next function is day function. The day function in Excel returns the day of the month as an integer between 1 and 31 based on a given date. The syntax is simple. You provide the serial underscore number argument, which is the date from which you want to extract the day. The function then returns the day portion of that date, making it easy to pull out the day number from any date in your spreadsheet. In this example, we'll reference the serial number from a cell to extract the day from a date. Just enter the day function, select the cell with the date, press enter, and drag down to apply it to other rows. In the next videos, we'll use it in various tasks and formulas to show how it can help in different scenarios. Our next function is hour. The hour function in Excel retrieves the hour portion of a time as a number between 0 and 23. It extracts the hour from a specified time, where 0 corresponds to 12 a.m. and 23 corresponds to 11 p.m. The function takes a serial underscore number argument, which is the time value from which you want to obtain the hour. In this example, you can see how we use hour function fo, extracting hour from values. If the value exceeds 24, the hour function divides it by 24 and takes the remainder as the hour. For example, 33 becomes 9 by subtracting 24, which works in this case, but this method won't be effective with larger numbers. In the next example, to extract the hour from the current time, we can use the hour function combined with the now function. The formula hour 0.75 returns 18 because 0.75 represents 18 hours in a day, 0.75 of 24 hours. Similarly, hour 0.5 returns 12 because 0.5 represents 12 hours of the day. AM or PM affects the result of the hour function. If you include AM or PM in the time value, the hour function will return the correct hour based on the 12-hour format. A date with no time portion specified is considered 12 a.m. or 0 hours. This explanation should be sufficient for now. We'll explore it in more detail in the upcoming. Excel is an effective tool for extracting the minute portion from a specified time value. It returns the minutes as an integer between 0 and 59. Serial underscore number is a required argument, representing the time from which you wish to retrieve the minute. You can input the time in several formats, such as text strings, decimal numbers. If a cell contains a time value, you can extract the minutes using a formula. In this example, we simply select the cell as the serial underscore number. The minute function allows you to pull the minute value into a cell or use it within another function, such as the time function. For instance, with time values in the first column, you can generate a new time that incorporates the extracted minutes. Next, we'll look at the month function. The Excel month function retrieves the month from a specified date, returning it as a number between 1 and 12, where 1 corresponds to January and 12 to December. Serial underscore number is a required argument that represents the date from which you want to extract the month. You can input the date either within quotation marks or directly select a cell containing the date values. The function will automatically retrieve the month from those date values. Let's explore another example. Suppose we have sales data that includes dates and sales values, and we need to calculate monthly sales. The first step is to extract the month from the date column using the month function. Next, we will copy and paste the extracted month values into another table. To get distinct months, we will use the Remove Duplicates option from the Data tab. Finally, we can calculate the monthly sales by using the SUMIF function. There are other methods, such as using pivot tables, to accomplish this task, but this approach is straightforward and helps you understand the basics. Starting with simple methods like these is essential for building a strong foundation. That covers the basics of the month function for now. We'll explore more advanced uses and applications of the month function in upcoming videos. Next, we'll look at the second function. The Excel second function retrieves the seconds component from a specified time, providing a number between 0 and 59. The serial underscore number is the required argument, representing the time value from which you want to extract the seconds. You can enter the time as text strings in quotation marks, decimal numbers, or results from other formulas or functions. In this example, we use a cell as the input, and the second function retrieves the seconds from the time value in that cell. Imagine we have a task to find out how many seconds a project or app usage lasts. We have start time values in the first column and end time values in the second column. If we simply subtract the second, end_time, from second, start_time, the result won't be accurate if the minutes differ between the two times. This is because the second function only extracts the seconds component, ignoring the minute and hour differences, leading to incorrect calculations. The correct method for tasks like this is to subtract the start_time from the end_time and then multiply the result by 86,400. This approach gives the accurate time difference in seconds, as there are 86,400 seconds in a day. This wraps up the basics of the second function for now. We'll dive into more advanced uses and applications of the second function in future videos. Now we will learn year function. The Excel year function extracts the year component from a given date and returns it as a 4-digit number. Serial_number is a required argument that represents the date from which you want to extract the year. You can either directly enter the date or select a cell containing the date values. We see in examples that in both cases, the function will return the year from the provided date. We have a task to calculate the tenure of employees. We'll begin by using the year function with the today function to extract the current year and subtract the year of the hired date. Although this method is simple, it might be inaccurate if the hired date falls later in the year than today. For a more precise result, we can use the datediff function. Keep in mind that in some versions of Excel, datediff might not appear as a suggestion, so you'll need to enter it manually. To calculate tenure in years, we'll input the hired date, then today, and finally Y as the parameters. This approach ensures that the tenure is calculated accurately, even if the hired date is later in the year than today. Next, let's explore the weekday function. This function returns a number between 1 and 7, representing the day of the week for a given date. By default, 1 corresponds to Sunday and 7 to Saturday, but this can be customized. Serial_number, the date for which you want to find the day of the week. Return_type, an optional argument that sets the day mapping. The default is 1, Sunday equals 1, Saturday equals 7. In our example, we'll select 2 as the return_type, mapping 1 to Monday and 7 to Sunday. Compare this with using 1 as the return_type to see how different mapping standards affect the results. You can use this function to get the full name of the weekday for comparison. This will display the day name corresponding to the date in cell E3. That covers the basics of the weekday function for now. We'll dive into more advanced uses and applications of the weekday function in upcoming videos. The WEEKNUM function returns a week number between 1 and 54 based on a specific date, with Excel starting its count from the week that includes January 1st. By default, weeks begin on Sunday, but this can be changed. It have 12 arguments. Serial_number. This is the required date for which you want to find the week number. It's recommended to use the date function to avoid errors that may occur from entering dates as text. Return_type. This argument is optional. It specifies the starting day of the week. If not provided, the default is 1, meaning the week starts on Sunday. If you want the week to start on Monday, you would input 2. There are 2 systems used for this function. System 1. The week that includes January 1st is considered the first week of the year and is labeled as week 1. System 2. Based on the ISO 8601 standard, which we will explain in the next function. In this example, we can observe the difference that occurs when choosing 1 or 2 for the return_type argument. Let's take January 3rd, 2021, which is a Sunday. If you choose 2 as the return_type, where Monday is considered the first day of the week, the WEEKNUM function will return 1 because January 4th, 2021, Monday, starts the second week of the year. So, January 3rd is part of the first week. If you change the return_type to 1, where Sunday is the first day of the week, the WEEKNUM function will return 2 because January 3rd, 2021, Sunday, marks the beginning of the second week of the year. Like other functions, We will also use this function in tasks and upcoming videos. Let's look to ISOWEEKNUM Function. The ISOWEEKNUM function in Excel calculates the ISO week number for a specific date, adhering to the ISO standard where weeks begin on Monday. Week 1 is defined as the first week of the year that includes a Thursday. This function requires just one argument, a valid Excel date, and returns a week number between 1 and 54 based on ISO rules. Remember, under the standard, week 1 is always the first week with a Thursday, and all weeks start on Monday. As we calculate week numbers using the ISOWEEKNUM function, let's use the WEEKNUM function in the next column for comparison. For example, we see that December 12th, 2024, is considered the first week of 2025 under the ISOWEEKNUM standard, but it's the last week of 2024 according to the WEEKNUM function because that day is a Tuesday. To find the ISO standard week number using the WEEKNUM function, you can simply set the type to 21. Additionally, let's apply the WEEKNUM function using both 1 and 2 for the return type and compare it with ISOWEEKNUM in a simple table. This comparison will clearly show the differences between the two functions. This function will be particularly useful when working with data from different countries or regions, as it allows us to adapt to their specific standards. That's it for this video. We've covered the basic date and time functions in Excel, giving you a solid foundation to build on. In the next video, we'll dive into more advanced functions that will take your Excel skills to the next level. Thanks for watching. Don't forget to like, share, and subscribe for more Excel tips and tutorials. See you in the next video.